Hello everyone, today we are deriving the derivative and integral of sine and cosine functions using the Euler's identity. So let's proceed. If you have a unit circle in the complex plane, then we can have e to the I pi equals cosine theta plus I sine theta. This is the famous Euler identity. This identity is one of the amazing equations in mathematics because it somehow connects the real and complex numbers in one equation. The I stands for the imaginary number or the square root of -1. If this is an identity, then we can input negative theta also. So we have e to I negative theta equals cosine negative theta plus I sine negative theta. Negative theta refers to the angle below the x-axis. So cosine negative theta is still positive cosine theta because its adjacent part is positive, while the sine negative theta same as negative sine theta because its opposite is negative. So this equation same as e to negative I theta equals cosine theta minus I sine theta. The beauty of having these two equations is that we can just subtract and add these both equations to define cosine and sine theta in terms of e to I theta and e to the I theta. Now to define sine theta in terms of e to the I theta and e to the negative I theta, we just need to subtract these both equations. So subtracting, we have the left hand side become e to the I theta minus e to negative I theta equals, since subtraction, the cosine theta cancel and we have 2I sine theta. Since we're looking for the derivative of sine theta, it is same as the derivative of the right hand side. So derivative of sine theta equals the derivative of the right hand side, and the right hand side same as e to the I theta over 2I minus e to negative I theta over 2I. Since e to the I theta is an exponential, its derivative is the same and multiplied by the derivative of its exponent. So the derivative of e to the I theta over 2I is e to I theta times the derivative of I theta is I, and the denominator is constant, so remains the same. So the first term is I times e to the I theta over 2I, and derivative of e to the negative I theta over 2I is e to negative I theta multiplied by the derivative of negative I theta is -1, and denominator is still constant, so we have negative I times e to negative I theta over 2I. And nicely, we can cancel the I both terms, and negative times negative is positive, so we have e to I theta over 2 plus e to the negative I theta over 2, same as e to the I theta plus e to the negative I theta all over 2. If you notice that this term e to I theta plus e to the negative I theta over 2 is exactly the cosine theta equals e to I theta plus e to the negative I theta over 2. So we can say that the derivative of a sine theta is just equal to the cosine theta. So that's how we derive the derivative of sine theta equals cosine theta. Before we proceed to the derivative of cosine theta, let's find the integral of cosine theta first. So if we have the derivative of sine theta equals cosine theta. We can just take the integral of both sides to find the integral of cosine theta. So we have the integral of the derivative of sine theta equals the integral of cosine theta d theta. So the integral of cosine theta is what we are looking for. Transfer integral of cosine theta d theta into the left hand side, and the integral and the derivative nicely cancel, so the right hand side becomes sine theta plus c. For the derivative of cosine theta equals to the derivative at the right hand side, so we have the derivative of cosine theta is equal to the derivative of the right hand side. On the right hand side, same as e to I theta over 2 plus e to the negative I theta over 2. Derivative of e to I theta over 2 is e to I theta times the derivative of I theta is I over 2 plus the derivative of e to negative I theta over 2 is e to negative I theta times the derivative of negative theta is negative I over 2. For the first term, we multiply the numerator and denominator by I times I, same as negative 1. The numerator part become negative e to I theta. Denominator become 2 times I, 2I. And for the second term, we multiply also by I, the numerator and denominator. So again, I times I is negative 1 times negative, we have positive. The numerator become e to negative I theta over 2I. Combine these two terms and factor out negative 1. We have the derivative of cosine theta equals negative e to I theta minus e to negative I theta all over 2I. As you notice that this term, excluding the negative sign, is same as the sine theta equals the e to I theta minus e to negative I theta over 2I. Then we can say that the derivative of cosine theta is same as negative sine theta. And also, we take the integral both sides to find the integral of sine theta. So we have the integral of the derivative of cosine theta equals the integral of negative sine theta. The integral of negative sine theta same as negative integral of sine theta. And we multiply both sides by negative 1. So we have integral of sine theta d theta equals the integral and the derivative nicely cancel, so remaining negative cosine theta plus c. Okay guys, that's how we derive the integral and the derivative of sine and cosine functions.